In the previous video, I discussed what is weighted tree and also how to calculate weight of the tree. Here, let's know what is optimal tree. Here it is the definition. If the tree carries the minimum weight, then it is called the optimal tree. If you calculate the weight of the tree, then it should be the minimum weight as compared with set of other binary trees. So here it is the procedure to construct the optimal tree. Let's go step by step. So consider an example, and for this they have given some weights as 4, 15, 25, 5, 8, 60. So there are 6 weights are given. The first step is to, as there are 6 weights, we need to consider 6 isolated vertices, 3, 4, 5, 6, and each of the vertex should be labeled A, B, C, D, E, F. And to construct the optimal tree, we need to arrange the given weights in the ascending order, increasing order, that is 4, and it should be enclosed within braces or brackets 5, 4, 5, and the next minimum weight is 8. Next we have 15, 16, and finally 25. So now we have taken isolated vertices, labeled, as well as arranged the given weights in the ascending order. The next step is to, we need to consider the 2 minimum weights in the given set of weights, and we need to add them and assign the added value to the new vertex. So here the 2 minimum weights are 4 and 5. Hence we are adding and assigning to the new vertex. Here the new vertex considered as V1, and now adding A, B with the weight 4, 5. If we add 4 and 5, we will get the weight as 9. And in the same step, we need to make again rearrangement. That is, again we need to arrange them in a ascending order. So if we see the weights in the previous step, 8 is minimum than 9. Hence, we will arrange with the weight 8. And next we have 9, and the next value will be D with the weight 15, E 16, F 25. In the same step, I have added 2 minimum weights as well as I did arrangement that should be in the increasing order for the newly added weight. So the arrangement will be like this: 8, 9, 15, 16, and 25. The next, again we need to add 2 minimum weights in the previous step. So that is, here the 2 minimum weights are 8 and 9. Again we need to add 8 and 9, and the resultant tree will be like this, and it will be assigned to the new vertex V2. Here we are adding 8, which is labeled as C, and 9, that is V1, and V1 which we got by adding the 2 weights, that is A, B, A with the weight 4 and B with the weight 5. Again we need to retain the previous structure. So here we are getting V2 by adding 8 and 9. So by adding 8 and 9, we are going to get the value as 17. So again we need to make the arrangement. Here we are getting a 17, but in the previous step, we have added 8 and 9. In the previous step, we have 15, 16. 15 and 16 are less than 17. Hence, we need to bring them into the front of the sequence. So here we have the name 15. Yes, 16 is D, which is 15. And next we have E, that is 16, 17. And finally we have F, that is 25. Now again it is in the order. The weights are 15, 16, 17, 25. And next minimum weights are 15 and 16. Let's add that and assign to the new variable v3. We are adding 15 and 16 with the label D and E respectively. And 16. And by adding 15 and 16, we are going to get the value as 31. And we can observe this 31 is greater than 17 as well as 25. Hence, we need to make a arrangement once again. So, 31 is greater than 17 and 25. Hence, I just retaining the previous structure C with the weight 8 and A with the weight 4 and B with the weight 5, and here we have vertex B1 that is 9, and here it is B2 with the weight 17, and the next minimum weight in the previous step is F with the weight 25. This is the arrangement we are having 17, 25, 31, and the next two minimum weights are 17 and 25. Let's add that. So the new vertex formed is B4. By adding, we have B2 with the weight 17 and retaining the structure C8 4 A B 5 V1 9, and next here we have F25. That is, we are adding 25. We are adding 17 and 25. We are adding 17 and 25, so that we are going to get the value as 42. And this 42 is greater than 31, which is the remaining weight in the previous step. Hence, we will bring that into the first position of the sequence. Hence, here we have V3. V3 is 31 and V3 is gained by adding DE with the value 15 and 16. Now finally, we have two weights 31 and 42. Hence, the final stages, we are going to get the root node and it is represented as R. Here we are adding V3 and V4. So V3 and here we have V4. V3 is having weight 31 and V4 is having weight 42. And V3 is having a structure that is DE with the corresponding weights 15 and 16. Whereas V4 is having the structure retained, that is here it is V2 with the weight 17, and here it is F with the weight 25, and again here we have another structure C with the weight 8 and A, B with the corresponding weight 4 and 5, and here it is the vertex V1 with the 9, and here F25. By adding the weights 31 and 42, we are going to get it as 73. The root node weight will be 73. Now we have constructed the optimal tree. Now Next, as usual, we need to find out the weight of the tree. To find out the weight of the tree, we need to consider weights that are assigned to the leaf node, and also it will be multiplied with the levels of the leaf node, levels of the weights of the leaf node. So let's draw the levels. Here it is the 0th level. This is the level 1. Here it is the level 2. Next we have level 3, and finally level 4. Now we know the formula to calculate the weight of the tree is given by W of t is equal to summation I is equal to 1 to n, I is equal to 1 to n, weights is multiplied with level of the weight. So that is equal to, here we have, let me consider one by one, A, B, C, D, E, F likewise. So here we have A with the weight 4 because A is the leaf node, and 4 which is at the level 4 only. Hence we are going to multiply weight into level, that is 4. Plus next vertex is B. B is having a weight 5. B is the leaf node, is having a weight 5. And 5 is also at the level 4, hence 5 into 4. Plus next AB is over C. C which is having weight 8, and C node, the leaf node C at the level 3, hence we are going to have 8 into 3. C is over. Next D. D is having a weight plus 15 into D is at the level 2, hence we will multiply that with 2, plus E is having a weight 16 into E is also at the, here we need to consider this nodes. E is also at the level 2, hence 16 into 2, plus E is over A, B, C, D, E, and finally we have the leaf node F. So F is having a weight 25, and F is at the level 2, hence 25 into 2. So finally we have 4 into 4, 5 into 4, 8 into 3, 15 into 2, 16 into 2, 25 into 2. So the value we are going to get for the optimal tree is 172. So this is how we need to construct the optimal tree. And here, whatever the procedure we have followed, this procedure is known as Huffman's procedure. So this is regarding the optimal tree. Thank you.